Have you ever wondered why there are so many different species on Earth? How did life evolve in single-celled organisms to the incredible diversity we see today? The answer lies in a concept called natural selection, proposed by the great biologist Charles Darwin.
Darwin's theory of natural selection explains how organisms with advantageous traits are more likely to survive and reproduce, passing on those traits to their offspring. Over time, this process leads on the evolution of new species.
So how does natural selection work? Well, it all starts with variation. Within any population of organisms, there is a range of variation in traits such as size, color, and behavior. Some of these traits may be advantageous in certain environments, while others may not be.
The second key component of natural selection is differential survival and reproduction. In any given environment, certain traits may make an organism more likely to survive and reproduce than others. For example, a bird with a longer beak may be better able to reach food in a deep flower, making it more likely to survive and pass on the genes to the next generation.
Natural selection is important because it helps us understand the incredible diversity of life on Earth. It also explains why some animals have wings, others have sharp teeth, and others can camouflage to blend in with their surroundings. It is also important because it explains how species evolve and how they adapt to their environment and how other species are related to one another.
Today, biologists continue to study natural selection and its effects on different populations. This research has led to important insights into topics like adaptation, speciation, and the origins of life itself.
Hey Jackie, have you all read this? It's a revolutionary book. It explains the process of natural selection where only the fittest organisms survive and reproduce.
Yes, I've read it too. It is a groundbreaking idea that challenges traditional beliefs about the origin of species.
But how does it apply to plants? Does it mean that only the strongest plants will survive? And what about geology? How does natural selection affect the formation of rocks and minerals?
Well, let's find out because there will be a panel discussion later on that talks about the Darwinian evolution. Let's go!
Charles Robert Darwin was an English naturalist, geologist, and biologist, widely known for his contributions to evolutionary biology. His proposition that all species of life have descended from a common ancestor is now generally accepted and considered a fundamental concept in science. Good evening and welcome to our panel discussion on the Darwinian Revolution. I'm honored to be joined tonight by some of the leading voices in the field of biology who will share their insights and perspectives on the impact of Charles Darwin's theory of evolution. John, let's start with you. Can you give us an overview of Darwin's theory and its significance?
In 1859, there was a groundbreaking revolution in both the scientific and religious realms. The Origin of the Species, authored by Charles Darwin, was published. The book changed how people approach biology forever and has fundamental impacts in modern science, religion, and other aspects of the society. Darwin's theory of evolution by natural selection is the idea that species change over time as a result of the interaction between genetic variation, environmental pressure, and competition for resources. It's a powerful framework for understanding the diversity on Earth and has been supported by an enormous amount of scientific evidence over the past century and a half.
Yes, Mr. Rojo.
But it's not just a theory. How can you be sure that it's true?
That's a great question, Angel. In science, a theory is the most supported explanation for a phenomenon based on multiple lines of evidence. Darwin's theory of evolution has been rigorously tested and confirmed with countless of experiments and observations across many different fields of biology. We will also discuss the terms such as fact, theory, and hypothesis as they are in use in the scientific literature and by the public.
As a journalist, I am interested in how Darwin's ideas have influenced our understanding of the natural world outside of academia. Cannot you speak to that?
Darwin's accomplishments were so many and so diverse that it is useful to distinguish three fields to which he made major contributions: evolutionary biology, the philosophy of science, and the modern zeitgeist. Although I will be focusing on this last domain, for the sake of completeness, I will put forth a short overview of his contributions, particularly as they inform his later ideas to the first two areas. Darwin founded a new branch of life science, evolutionary biology. Four of his contributions to evolutionary biology are especially important as they held considerable sway beyond that discipline. That is, the first, the non-constancy species of or the modern conception of evolution itself. The second is the notion of branching evolution, implying the common descent of all species of living things or on Earth from a single unique origin.
As someone who comes from a religious background, I've struggled to reconcile Darwin's ideas with my faith. But I also recognize that his theories have helped us to better understand the interconnectedness of all living things and the beauty and complexity of the natural world. For many people today,
the details of Darwin's religious journey from Christianity to agnosticism and its relationship to his theory of evolution take on much importance. For some, such as those who have transformed his visage into a singular Christmas ornament, Darwin has become an icon for atheism, even though Darwin refused to identify with atheism himself.
Absolutely. Darwin's ideas have revolutionized not only biology, but also fields like paleontology and ecology. By studying the fossils record and tracing the evolutionary history of different species, and we can learn so much about the past and present biodiversity of our planet. Ecology. And lastly, by understanding how species have adapted to the environments over time, we can better protect them from extinction and preserve the ecosystem they depend on.